All right, so our next lesson is on conversions. Units are amazingly important in mathematics, science, and engineering. They are how we decide on what constitutes the number one, for example, 1 gallon, 1 pound, so on. We often need to convert from one unit to another in practical problems. In this situation, we can almost always use proportional reasoning to do the job. So you might remember from last year, at some point in math, a proportion is nothing more than two ratios that are equal to each other. So something like, 1/2 equals 3/6. Okay. So what we're going to do is use what they call proportional reasoning in order to do a conversion. And really, the one thing you have to remember is that you're focusing on the units, okay? And we'll go over this problem in a moment, but here's gallons. Anytime you set up your ratio, which is your fraction, to multiply by, you have to make sure that the units, like units, are in the opposite position. So here we have gallons in the top of the fraction, gallons in the bottom, okay? And you'll see that as we go through. So basically, what we use to make these conversions is what we call a conversion factor. And that is simply a ratio that shows that the relationship between two quantities. So for example, let me write up here, in 1 foot, there are 12 inches. Okay, that would be an example of a conversion factor. Now, depending on how you need to use it, you may also write that as 12 inches are in 1 foot. So again, it's two equal quantities and the fraction can be flipped. Hopefully as we go along, you'll see how this all works. You will always be given the conversion factor. There are very few that you need to know yourself. So for example 1, you're mixing some concrete for a home project and you've calculated according to the directions that you need 6 gallons of water for your mix. But your bucket isn't calibrated, and that just means that you have to calibrate your instruments when you use them. It's a whole science thing. Anyway, so you don't know how much it holds. On the other hand, you just finished a 2-liter bottle of soda. If you use the bottle to measure your water, how many times will you need to fill it? So basically, we want to see how many 2-liter bottles we need, okay, in order to get 6 gallons of water. So if you look over here, we start with the 6 gallons, okay, because that is our starting amount. We eventually want to end up, though, with liters. If we know how many liters there are in 6 gallons, then we'll know how many 2-liter bottles to use. So here's the example of where we use our conversion factor. And that's our conversion factor, right here. In 1 gallon, there are 3.785 liters. Now, that conversion factor could have been used as 1 gallon over 3.785 liters, or the flip of that, the reciprocal of that. It all depends where your words are, where your units are. So we have 6 gallons. Now this one right here isn't a unit. It's just there kind of as a placeholder. So since gallons are in the top of the fraction, when we do our conversion factor, gallons have to be in the bottom. Liters are in the top. What happens is that, as you can see here, we cross out the gallons, and then we're simply left with a calculation. 6 times 3.785 liters. And we would do that on our calculator. And we would get 22.71 liters. That's how many liters in 6 gallons. Remember the questions asking, though, how many 2-liter bottles do we need? Now, here they again show you a conversion. I would think most of us would know just to divide by 2, okay? And when you divide by 2, we get 11.355 bottles. Okay. All right, so let's do a few of these together. We're probably going to focus more in class on these, okay, because I get it. They can be a little tricky. Okay. So John has traveled a total of 4.5 miles. If there are 5,280 feet in each mile, how many feet did John travel? So we want to start with how far John traveled, which was 4.5 miles, and we just stick it over 1. We now need to multiply by something to convert that to feet. So don't worry about the numbers, okay? Look where miles is. It's in the top of the fraction on the left. That means miles has to go on the bottom of the fraction on the right, and feet goes on the top. And now we simply fill in the numbers. There are 5,280 feet in 1 mile. The miles cancel. And you can rewrite this if you want, but you don't have to. So now we have 4.5 times, this is one of the few times I'll use an X for multiplication, 5,280 feet. You put that in your calculator and you get 23,760 feet. So again, I just multiplied. Okay, let's look at one where we actually have to do 2 conversions. If there are exactly 2.54 centimeters in an inch, how many centimeters are in 1 foot? Show the work that leads to your answer. Okay, now you have a couple options here. Because we're given a conversion that involves centimeters and inches, but we want to know how many are in 1 foot, we could go through the process twice. But what I would recommend here is say, well, how many inches are in a foot? We know there are 12 inches in 1 foot. Okay? So if I have 2.54 centimeters in 1 inch, I want my final answer to be in centimeters. So this time, I'm not trying to get rid of the centimeters, I'm trying to get rid of the inches. So what do I know? I know that there are 12 inches this would be your 1 foot. So I know there are 12 inches in 1 foot. Now the inches cancel. I'm left with 2.54 times 12, which is 30.48 centimeters. Okay, number 3. Sometimes it is helpful to be able to convert so that a rate makes more sense. Take a look at the next problem. So a bathtub contains 14.5 cubic feet of water. If water drains out of the bathtub at a rate of 4 gallons per minute, then how long will it take to the nearest minute to drain the bathtub? There are 7.5 gallons of water per cubic foot. Show the work that leads to your answer. Okay, so the rate that we're given is 4 gallons per minute. Okay, we don't, however, know how many gallons are in the bathtub. We know how many cubic feet. So the first thing we're going to have to do is change the 14.5 cubic feet into gallons. And they told us right here at the end, there are 7.5 gallons of water per cubic foot. So again, I set up my conversion factor. I want to get rid of the cubic feet, so they must go on the bottom. Gallons must go on the top. And now I fill in what they told me, 7.5 gallons to 1 cubic foot. The cubic feet will cancel. And now I multiply 14.5 times 7.5, and I get 108.75 gallons. And that's in the bathtub. Now remember, the question's not simply how many gallons. The question actually is, how long will it take to drain the bathtub? So here's where we go back to our rate. The bathtub drains at a rate of 4 gallons per minute. Now you can keep going where we are here with a conversion. Some people though like to just start over. So not start over, but rewrite. So we have 108.75 gallons, and we want to know how many minutes. Well, right here we're told 4 gallons per minute. So where do the gallons have to go? They have to go on the bottom. Minutes have to go on the top. And 1 minute, 4 gallons. So the gallons will cancel. And now here you have a couple choices. You can multiply first across. So we would get 108.75 minutes over 4, and then simply divide. Or you could have multiplied 108.75 by 1/4. Okay, so I'm going to use my calculator. 108.75 divided by 4 is 27.1875, and it said to the nearest minute. So that would be 27 minutes. I can spell. All right. We're actually going to skip number 4 for now, and we'll work with that in class. All right, number 5, we can also convert the ratio of 2 quantities or rates into different units if need be. So for number 5, it says one interesting conversion is from a speed expressed in feet per second to a speed in miles per hour. We sometimes think better in miles per hour because that is how the speeds of our cars are measured. So convert a speed of 45 miles per hour into feet per second, given that there are 5,280 feet in a mile. Okay. So really the difference here is that when we set up our first fraction, we have 45 miles, but instead of just a 1 in the bottom, we actually have another unit. We have 1 hour. Okay, so the speed is 45 miles per 1 hour. And we want to change this into feet per second. So basically, we're going to have to do 2 conversions. Let's not worry about the hours right now. Let's just do the feet. So since there are 5,280 feet in a mile, think about where would miles have to go. They would have to go on the bottom. Feet would have to go on the top. And then we plug in 5,280 feet per 1 mile. The miles cancel. And when we multiply across, we get 237,600. And that would be feet. But in the bottom, look at what we still have. We still have 1 hour. Okay? We want to now change the hours to seconds. So we're going to multiply by another conversion factor. Now, this is the first time we're trying to get rid of something that's on the bottom, the hours. So that means hours have to go on top. Seconds will go on the bottom. Now, here's where I'm going to give you a conversion. Hopefully, we all know that there are 60 minutes in 1 hour, and there are 60 seconds in 1 minute. So think about it. How many seconds must there be in an hour? All you would do is multiply 60 times 60, and it's 3,600 seconds in 1 hour. So that's what I'm going to fill in. In 1 hour, there are 3,600 seconds. So watch what happens. The hours cancel. The feet stay. So our final answer is going to be in feet per second. And now we have to do the calculation. So again, if you look here, you can do 237,600 times 1 over 3,600. That's fine. Or you could just divide. This time I'll multiply. So 237,600 times 1 over 3,600. Oops. And we get 66 feet per second. Okay, our next part of this problem says, and this might be a little outdated, maybe you've never even heard of him for all I know, I don't know. The current fastest human is Usain Bolt from Jamaica. In 2009, yeah, that's a long time ago, Usain ran 100 meters in a blazing 32.2 feet per second average speed. How does this compare to a typical car driving speed? Okay. Now, the thing you have to realize here is the 100 meters have nothing to do with this. We're interested in his rate. His rate was 32.2 feet per 1 second. Now, typical car driving speed is miles per hour. So at this point, it really does not matter which one you convert first. You can do the feet to miles or the seconds to hours. I tend to start with the unit that's on the top of the fraction in the numerator. So I want to change my feet, which would have to go on the bottom, to miles. Now, in the above problem, they already told us there were 5,280 miles. Nope, that's a lie. 5,280 feet in 1 mile. So the feet would cancel. And if I do 32.2 times 1 over 5,280. Remember, that's the same thing as just doing 32.2 divided by 5,280. Okay, I get this value here. So here's where something comes up that I'm going to suggest. If you want to work with this number, that's fine, but you have to work with the whole thing. You cannot round. That's kind of a big number to write down. So here's what I'm going to recommend instead. Instead of doing the multiplication or the division right now, let's continue. Let's not actually do the math yet. Let's continue and change the seconds to hours. So you almost have to pretend that 1 mile over 5,280 feet is not there. What would you multiply by to change seconds to hours? So seconds would have to go in the top. Hours would have to go in the bottom. And we know, again, from the previous problem, there are 3,600 seconds in 1 hour. So the seconds would cancel. And look what I'm left with, miles per hour. So now I do my multiplication. I have 32.2 times 1 over 5,280 times 3,600. Now, I already did the multiplication, but I'll do it again. So now you would put in your calculator 32.2 times 1 over 5,280 times, oops, not there, times 3,600. You don't have to put that over 1. And now they didn't give us a rounding direction, so I would leave the answer as 21.9 54 repeating. So 21.9. Now the repeating part is just the 54. All right, I think we'll stop there. So tomorrow in class, we're going to do exercises 4 and 6 together. You can certainly try them if you'd like. And with the additional practice, there might be a couple that we don't do. So I would not necessarily jump ahead.